What is up, winning team? Hello and welcome back to our book series Beyond the Veil, exploring the bubble theory and the fourth dimension, a beginner's journey into high dynamics in modern physics, written by Jamil Chamberlain. Guys, we're in chapter 14, and can you believe? If you want to know what this is all about, we've been delving into the dimensions of the universe. And listen, outside of this book, the way I've been studying all of this, outer space, the universe, the galaxies, the bubble theories, all this outside of this, it's going to get even juicier. So let's finish off the book. We've got one last chapter. I can't believe we got all the way through this entire book together, but it's not the first time we've read through something together. And let's just get straight into it and see what we're looking at today. We're looking at the future horizons. Hold on, there's something in my eye. Bear with me. Honestly, this is one of the main reasons I actually wear mascara, because a lot of my eyelashes naturally turn into my eye. Like, it's so weird. It's one of those things. I always find one. I always pluck one out, and then another one reappears turning inside. And apparently it's like a thing. Anyway, so sometimes that's one of the reasons sometimes I even wear mascara, is just to get them to stay up. Anyways, chapter 14, The Future Horizons. Introduction. Have you ever embarked on a journey with no clear destination? Driven solely by curiosity and the desire to uncover the unknown, watching One Piece. This is the one thought that came to my mind. The pursuit of scientific understanding often mirrored such a voyage, filled with exploration, challenges, and moments of revelation. In the realm of theoretical physics, developing groundbreaking ideas like the bubble theory requires not only intellectual rigor, but also a profound sense of wonder and perseverance. This chapter delves into the personal and professional journey behind the bubble theory, highlighting the motivations, challenges, and inspirations that have shaped its evolution. So we now kind of understand this whole concept of the bubble theory now, right? And which I didn't realize was such a popular concept in science. But here we go. This is why we do this stuff. This is why we're lifelong learners here at the winning team. #winning strategies. But yes, so we've learned a lot now about the bubble theory. So this is so interesting to get into a bit more of the future horizons. What was the purposes of all of this, and so on and so forth. So personal motivation. From a young age, gazing up at a night sky instilled a sense of awe and curiosity about the universe's vastness and mysteries. The shimmering stars and the intricate dance of celestial bodies sparked questions. What lies beyond our visible horizon? Are there realities parallel to our own? These contemplations laid the foundation for a lifelong quest to understand the fundamental nature of reality. This also goes to highlight something that I actually wanted to mention in another video that I don't think I ever did, which is that historically, a lot of these concepts in science are based off of people in science actually just stopping and observing the world around them. If you look at the concepts of people like Albert Einstein and his law of relativity, how he changed the law of relativity, and even Newton, who understood about gravity because he thought about an apple dropping and he noticed the moon staying in the sky, and how he correlated that whatever force was acting on both of them had to also have been the same force, which sent him on a rabbit hole. Like how Einstein realizing that the difference between the distance and speed and time, and how the concept that time can potentially dilate, and these types of things, was all based off of actual observations. And scientists, in and of everything, at a basis level, are observers. You observe. As a scientist, you have to be able to observe and comment and notice changes and put things together. So a lot of times people are quick to kind of look at scientists as these crazy, wild creature, rare beings. But in actual fact, we can all be scientists if we all paid a bit more attention. I've said this to people before. People sometimes wonder how I come to some of my conclusions. I spend a lot of time out in nature, and I spend a lot of time observing in general. I observe everything all the time. I love being able to observe things, and you do learn things just from doing that, because then you're one with yourself and you can ask questions. Unfortunately, we live in a world where we're purposely kept so busy that we don't do that. And that's also, I believe, a strategy to keep us dumb. Let's continue. The quest for unity in physics. One of the most compelling motivations behind the bubble theory is the desire to unify the fundamental forces of nature. The apparent disconnect between quantum mechanics and general relativity has been a persistent challenge in physics. The aspiration to bridge this gap, a cornerstone of theoretical physics, fueled the exploration of high-dimensional interactions and the formulation of the S-energy field concept. Now, here's another point to take home about all of this. The reason why they're even considering, you might think, oh, the fourth dimension, this sounds crazy. That's not scientific enough. They haven't got enough empirical validation, whatever. But there's a reasoning why this is happening. Quantum mechanics and general relativity, there's a disconnect between quantum mechanics and general relativity. So these are two accepted, understood, trusted fields of thought. But at this current stage, there isn't a way to interlink the two. Similar to, let me get my notes because I wrote it really well in my notes. Here we go. That's why it's good to always take notes. Always have a notebook, guys. I'm somebody who always has a notebook, and I write everything in this notebook, right? What was I going to say? Let me see. Sorry, guys. I'm looking at my... Okay, let me not get into all of this, but it's going back to Einstein's theory of relativity, and what he noticed was the issue between the work of Newton and Maxwell and the laws of motion and the laws of electromagnetism. But we're not going to go into all of that because that's going to take us down the side quest. So anyway, as I was saying, there is reasoning basically for why these things are done, and there are specific theories and beliefs that we have that don't actually fully answer each other or don't necessarily connect together. And so we need to address that, because obviously how can they both be true but then not connect? That doesn't make sense. That's like saying you're having two pieces of the same puzzle, and yet those two pieces of the puzzle don't fit together. It doesn't make sense, does it? So a desire to simplify complexity. The universe's complexity can be overwhelming, but there is a beauty in seeking simplicity amidst intricacy. The bubble theory aims to distill complex phenomena like dark matter, dark energy, and quantum entanglement into a cohesive framework that is both elegant and accessible. This drive to simplify without sacrificing depth has been a guiding principle throughout the development of the theory. The scientific process. Formulating the hypothesis. Every scientific journey begins with a hypothesis, a tentative explanation for observed phenomena. For the bubble theory, the hypothesis emerged from pondering the limitations of existing models and envisioning a higher dimensional framework that could account for unresolved mysteries. This initial idea served as the seed from which the theory would grow. Here's what I want to throw out there, just as a note, that hypotheses are always tentative in nature. So again, for us to be able to learn anything, sometimes you have to start with something that doesn't have as many legs or as much of a backbone as you'd like, but you're only going to know once you actually pursue the knowledge. Hence why I said, and I say this in a few of my videos, just because someone can't prove to you that something is right, doesn't mean they're not right unless you can prove that person is wrong. And hence why we have hypotheses, and hence why we do the work. Somebody has to be crazy enough to question or consider something different for us to even be able to figure it out. So that's something I just wanted to highlight. Mathematical modeling and simulations. Translating conceptual ideas into mathematical models is a critical step in validating any theory. Rigorous mathematical formulations were developed to describe the interactions of bubbles within the fourth spatial dimension. Computational simulations played a pivotal role in testing these models, allowing for the visualization of higher dimensional dynamics and the prediction of observable effects. So again, a key concept here, and also because I've done my own work in computational, although I've done computational chemistry, for us to even be able to conceptualize some of these things, we have to find a way to even conceptualize it in the first place, which is what these computational modeling can help with, is one of the examples here that's being used of what we can help. Some of the things we're trying to understand, because we don't understand them, it's like there's something is the answer, right? But you're trying to work back from an answer that you don't have, right? So it's almost like having an equation that equals something, right? And you're trying to find out what the equation is without knowing what it even equals, right? And in general, that's the difference between an equation and an expression. An expression tells you that, expression tells you how to calculate something, but as in without necessarily having the values that are in there, right? In an equation, you can actually get to an answer. You can actually get to a root. So that's what's quite fascinating to me about all of this, is we essentially have an answer that we don't know. We have some things we do know, and we're trying to work backwards. And it's quite funny because even algebraically, you can only have one equation, one unknown. In order to work out two unknowns in an equation, you need two unknowns, you need two equations, and so on and so on and so forth. So again, we have to kind of go backwards to make these simulations, these computations and things just to even visualize what we're talking about, to figure out what we don't know that we need to know about what we need to know in order to know what we don't know to get to what we don't know. And that's actually what science always is. Science is always trying to figure out. We don't actually know what the thing is. So I likened it to searching for the One Piece. There's a One Piece and we know that the One Piece can do something, but we also don't know exactly how to get to the One Piece. The only way we're going to get the One Piece is just by embarking on the journey in pursuit of the One Piece and following all of the clues as we go. Similar to doing an algebraic equation. If you're doing an algebraic equation, right, especially a difficult one, a lot of times people struggle with algebra in school. I say this all the time because you don't know what the answer is going to be and you don't know where the question is going. You just have to use whatever you have now, figure that out, and then figure out the next thing. And then once you have that, see how that can help you figure out the next thing. And then eventually you find yourself at the answer. But the point is, you may not know, and this is what, again, seems counter-scientific, but it's literally exactly how science actually works. So we've got collaborative efforts. Science thrives on collaboration and the exchange of ideas, engaging with fellow physicists, mathematicians, interdisciplinary scholars, chemists, I'm adding, provided invaluable feedback and perspectives that enrich the bubble theory. No, but we do need to have more interdisciplinary collaboration. Overcoming challenges, navigating uncharted territories. Venturing into higher dimensional theories presents unique challenges, both conceptually and mathematically. The lack of empirical data, which is, again, the key thing, that reason why people trust in science as opposed to, say, the supernatural. The lack of empirical data and the abstract nature of the concepts necessitated innovative thinking and... Okay, let me read this whole sentence again because I'm getting distracted in my head by thinking about videos. The lack of empirical data and the abstract nature of the concepts necessitated innovative thinking and perseverance. Overcoming these hurdles required a balance of creativity and discipline, pushing the boundaries of conventional scientific inquiry. So again, balance of creativity and discipline, which words that don't necessarily seem like they both work together, but are both necessary. Balancing simplicity and complexity. Striking the right balance between simplicity and complexity is an ongoing challenge. While the goal is to make the theory accessible, it must also account for the intricate behaviors observed in the universe. This balance was achieved by focusing on foundational principles that could elegantly explain multiple phenomena without becoming over convoluted. So here, the way I would describe this, it's almost like how the difference between simplicity and complexity, you could liken it to how... hold on one second. So, for example, me and my eyes. Anyway, what I wanted to use the example of was, what example I was going to use? Breathing. The simplicity of talking about breathing is to say that we breathe in oxygen, and then from the air, we breathe in the air, and the air gives oxygen to our bloodstream, which brings oxygen around our body, which is how we have respiration. The complexity, if you wanted to go a stage further, would be to say that glucose and oxygen come together to form carbon dioxide, water, and energy. If you wanted to go even deeper on the complexity, you'd say C6H12O6, which is glucose, plus 6O2 gives, 6CO2 plus 6H2O, as in 6 carbon dioxide, 6 hydrogen, because you have to account for the ratios. Here's me being a chemist again, right? If you wanted to go even deeper, then you actually talk about what's delivering what where. So we have to introduce ATP, which is the form of energy. I think it's adenine triphosphate, which again, you can then split into the ATP, which has the ADPDH, and all this other stuff. The electron transport chain, what's actually going on in your cells and your cell organelles, it gets complex, right? What am I trying to say with all of this? While I'm trying to butcher my memory of aerobic respiration. Again, specific, because respiration can be aerobic or anaerobic. Aerobic with the oxygen, you guys know. Why am I saying all this? With all things in science, there has to be an element of simplicity, as in we can all observably, as you're listening, speaking, whatever, your body is naturally respiring on its own aerobically, right? Through your breathing and whatnot. But in order for us as scientists to know what we're talking about, and to know the truth and to be able to prove what we're saying, there has to be the element of the complexity where we can explain down to, the electron level, and as ideally even smaller, like, again, going back to the elementary particles and fundamental forces, what's actually happening in a complex sense so that we can cover all of our bases. In the same way that only being able to explain something in its complexity isn't actually beneficial to scientists, potentially, especially in terms of collaboration and furthering of science, as we'll know from the scientist I always mention on my channel, my favorite science, Gregor Mendel, who was considered a mathematician or a biologist. And again, his work was too mathematical, too complex, that people just thought he had a bunch of calculations. What's bro talking about? When in actual fact, he's the one who made the big understanding and the big breakthrough as far as us understanding what actually goes on with our genetics. That was a huge change for the scientific community, and the fact that, you know, like I said before, we're not just 50-50 of our parents. There are genes that play. There's dominant recessive alleles. There's changes that can happen based on the fact of whether you're a male or a female. There are some genetics that specifically come through the male genome because of the Y chromosome. Color blindness is one of those things. There's a whole bunch of different things that actually affect the genetics of what actually goes on. And it was all discovered by a mathematician, but his work was too complex to explain, so people didn't get it. So there has to be both. And again, you guys can see why it's not so easy to just trust in these things. But then also we see how that's used as an exploitative tactic for the ignorance of the non-scientist, because this is what Sabine Hossenfelder was bringing up. You guys will see earlier in this series. Oh my gosh, I completely forgot to say that the playlist and the book and extra information, the more complex stuff, is all linked in the description. I completely forgot to say that. She said how, you know, a lot of scientists use the over-complex information, over-complex conversation, vocabulary and stuff to get other people to sound like they know what they're doing, get away with a lot of stuff because people don't know any better. If you're a rich person, if you're a rich billionaire and you just want to put some money into the next big thing for science, and you've got like a 10 million you want to invest in something, all a scientist truly has to do is speak as much scientific jargon as humanly possible that ends with, and I plan that you will produce a 70% profit. Boom, bang, boom. You're going to get the job done, right? Because that person doesn't really know what you're talking about, and they're trusting you know what you're talking about. So that's another way that scientists can actually exploit not just the fund investors, but also the public at large, because they just have to talk in such a way that they sound so much more intelligent, right? Even though, like I said, if you truly understand anything, you should be able to simplify it to anybody. Anyways, interdisciplinary research opportunities. The bubble theory opens avenues for interdisciplinary research, bridging gaps between physics, mathematics, computer science, and philosophy. This cross-pollination of ideas fosters a holistic approach to solving complex problems, leading to breakthroughs that transcend traditional disciplinary boundaries. I very much agree with this. I very much personally, as somebody who has worked with and has known scientists of different specific areas of expertise, I do feel we all have different advantages at the ways that we look at things based on where we're coming from, in terms of the individual side of the overall idea of science, the way that we look at it, right? And so I think it's important that we can acknowledge that amongst each other and work together, because how we all look at the same thing is going to be slightly different to each other. Like, even the way that I look at this, I can tell this book is written by a physicist as opposed to a chemist, for example. Even if it was a chemist that had studied this just as much, it wouldn't sound like this, and it would be quite different to this, because we all kind of have a different way of we're seeing the same stuff, but we have different levels of expertise or specialism amongst it. So it's best for us to, as it says here, cross-pollinate. It's added to my already understanding of quantum mechanics from a chemistry perspective. I've added to that from studying into all of this, and it's also made me even go back and rethink a lot of the things that I've said also myself, or I've learned from a chemistry standpoint. Promoting scientific literacy. In an age where scientific literacy is crucial, the bubble theory aims to make advanced theoretical concepts understandable to a broader audience by demystifying high-level physics. The theory empowers individuals to appreciate the beauty and complexity of the universe, fostering a more scientifically informed society. Now, I don't actually believe that the science industry of today wants that to happen whatsoever. I'll be honest. I don't believe that scientists want society to be more scientifically informed, because I believe that the powers that be want to control all of the intelligence and the knowledge for themselves. Going much back to what I was saying about One Piece before, and how in One Piece, the world government is coming up against the pirates are all out to search for this One Piece, right? And I believe that the One Piece is going to be the knowledge that the world government is hiding from everybody. And I believe it's a similar story as what's happening in the world today. Go and check out my my One Piece playlist if you want to hear about that more. And so, again, purposefully, certain individuals are being entrusted and certain things are being done in certain ways for the people who are allowed to be a part of it, who are under the thumb of, certain individuals, similar to how Vegapunk is under the thumb of the world government in One Piece. And why I believe that in schools, you're purposely taught subjects like maths and science badly. I can only speak for this country where I've both learned my education here, most of it, and taught that I believe it's being taught badly on purpose, because I do believe that they're trying to keep certain information away from the average public, because then the average person could produce potential theories and books like such, which if people understood more about their universe and more about things, then removes their level of control, which we won't get into too much of that because this is not what this series is about. So finally, he ends off here. The journey of discovering and formulating the bubble theory has been one of the exploration, perseverance, and unwavering curiosity. From the initial sparks of inspiration drawn by the cosmos to the meticulous development of mathematical models, each step has contributed to a deeper understanding of the universe's fabric. By overcoming challenges and fostering interdisciplinary collaboration, the bubble theory stands as a testament to the power of human inquiry and imagination. As we continue to push boundaries of what we know, the theory invites us to embrace the unknown, encouraging a continuous quest for knowledge and the ever-expanding horizons of discovery. So that is that for the end of the book. Can you guys believe there's so much more to go in our discoveries? And of course, if you guys want to purchase the book for yourself, there is a glossary here that what the S energy field is, bubble, fourth dimension, entanglement, gravitational lensing, a few concepts that came up. There's further reading, a number of different books, articles, educational websites, online lectures and videos, a whole bunch of different things. And then we've also got about the author, which I'm going to do separately, the about the author and the acknowledgements, because I feel like it's nice when you've done a piece of work to actually address those types of things. And also the about the author usually comes at the beginning. I found it fascinating that he chose to do that at the end. Honestly, it feels like the most physicist type of move, or just scientist type of move in general, where it's kind of like, listen, let me tell you about this stuff. We can figure out who I am later. Like, let's get straight into it, right? So we'll do a bit about that and a bit of just like a conclusional video. But there you go, ladies and gentlemen. We've done the whole entire book, and this is not the end. So if I were you, I would buckle up your seats. I would throw anything in the comments that you guys might want me to look into or talk about to continue this journey. Let me know your thoughts in the comment section. Reach out to me personally. People have reached out to me personally because of my videos about this, and the conversations are getting more and more juicy. And so get involved. The book is linked in the description on Amazon. Go and check that out for yourself. We've also got the link with the whole playlist. So catch up, because listen, I have so many thoughts that I've been saving and questions. I also have some questions I'm going to ask directly to the author as well, which I'll be including in the videos. I have so much to say, but I wanted to get through the book first to make sure that I've at least understood where we're starting from. This has been a really good time. I hope you guys have been enjoying this. This is absolutely not the end. Stay tuned. All the videos will be inside the playlist, which you guys will find in the description box. Come back to the next video where we're going to do about the author and his acknowledgements, etc. And just kind of a conclusion of this. And I may even trickle in a little bit more of some of my thoughts about where I want to go next with this whole series. So if you guys have enjoyed this, don't forget to hit that subscribe if you're feeling the vibe and you want to join the tribe. Because if life's a game, let's play to win. God bless every single one of you. God loves you. I love you. And I'll see you in my next one.